Hello, my name is Marc Curry. I'm a product manager with Red Hat, and I'm focused on the OpenShift container platform. One of the things that I'm involved with is the OpenShift and the containerization projects that we have and how it is that those tie into OpenStack and vice versa. So today I'm going to talk briefly about, provide you with a really high-level introduction to integrating containers with OpenStack networking. So don't have a lot of time, and this is a fairly big topic, so I'm going to just jump right into it. So the main question here is, how is it that we do this? So fortunately, containers have very similar network requirements to OpenStack with maybe a plus. And I'll explain what I mean by that. So some of the common things you would expect to be the same in enterprise networking: high availability, resiliency, load balancing, security, we need multi-tenancy. All of these things are common between the two. So that part, fortunately, is the same. Maybe the plus, however, though, is the understanding that containers were designed to come and go, and sometimes rather rapidly. So customers sometimes want to peak up the number of containers they have to scale up to meet demand. And the moment that demand is gone, they want to scale back down again as well to reduce costs, especially if they're using a cloud provider. So there's automation of scaling that goes on, and part of that challenge is the constant update of the firewall rules, the IP table rules, the routes, the load balancing information of all these different instances you have of your particular application. So that challenge is something that maybe isn't as common inside of OpenStack. So to that end, I'm the OpenShift product manager, but I'm not going to kill you with OpenShift. But I am going to use it as a very common example of an enterprise-grade build of Kubernetes with Docker. So a lot of people do this. It's a very common deployment. And so I'm going to use OpenShift as an example, since that's our ecosystem that we build around that common deployment. But everything here, I say, pretty much applies to DIY. So core concepts quickly. Container image, it's really just nothing more than a Docker formatted bundle, so to speak, of all of the things you need in order to run your process. There's the container, which is the actual running instance of that bundle. There is the concept of a pod. And what a pod is it's a group of one or more containers that have something to do with each other, and maybe you bundle together into this pod entity. I'll explain more about that. There's the concept of a service, so maybe a web server. You want something to come in, look for this instance of a service that is the web server, and have that service figure out, okay, where is everybody located at that I need to communicate with? And then there's the concept of a project, and this is where multi-tenancy comes in, and probably the closest analogy to OpenStack is the concept of a tenant. So let's do a real quick overview. So SDN is a pretty complex topic, and I'm not going to possibly be able to cover everything in a low-level detail, but you at least deserve a high-level view of what goes on in a typical enterprise deployment. So on the left-hand side, you see that there are 3 pods listed there. And don't forget, those pods are really instances of one or more containers that have something to do with each other. Those pods, when they instantiate, they actually ask for an IP address. And whereas that typically comes from Docker, in this case what happens is Docker almost immediately hands it off to Open vSwitch, OVS. And so as part of the deployment, if you're doing a DIY, you would install that yourself. As part of OpenShift, that's automatically deployed as the default scenario. So they get their IP address, and all their routing information gets bundled up into the OVS bridge. And so, for example, if you have maybe one pod that has, let's say it is a web server, you have a Tomcat instance, and maybe in another pod you have a database that Tomcat has to refer to deliver a web page to a customer's cell phone, then the way the communication works is each one of those pods has on the OVS bridge a virtual Ethernet interface. And so their world, they have their own Linux network namespace. So their whole world is looks like they're the only thing out there. So their ETH0 interface is going to connect to this virtual Ethernet interface on the OVS bridge, And then from there, the OVS bridge is quite comfortable and familiar with where everybody else is on the other pods. And so the OVS bridge has the ability to redirect them to the pod they need. So how do they tell OVS what they need? It's all done through like a naming scheme with some built-in DNS. So they basically say, OVS, I need my Mango instance, or whatever, and OVS redirects them to the correct pod. So that's one scenario, but what if we have a larger cluster of these pods? We want to be able to spread them across lots of different instances, or nodes, or VMs, or bare metals, however you want to address that. So the problem is the networking can get really complicated really quickly, and also you start to run out of address space. So what happens is OVS actually has the ability, and so if you follow the blue line in this particular diagram across the top, OVS has the ability to recognize the fact that you're going to somewhere on another node, and it has the ability to then encapsulate your traffic and give it a VXLAN ID, and basically flatten out that network namespace so that you can get to some external pod on another, maybe VM or physical node somewhere else. The bottom route there, where you see the Linux bridge, that's really for any kind of a pod that says, I don't really want to be a participant, or maybe I can't be a participant in your SDN solution. So for backward compatibility, for example, there's that Linux bridge which remains. And those Docker containers, they can still talk to each other without using SDN, and they can still get to the outside world, but they can't participate with the other pods that are part of the SDN. And finally, the last one I have on here is, well, what if we want to get to an external system altogether? Well, the pods have the ability to, when they connect with the OVS bridge, OVS says, I know you're trying to get to the outside world, so instead I'm going to route you through a tunnel that takes you through an IP tables firewall, and I'm going to NAT your IP address. And so it NATs the IP address and gives it something that actually works on the actual real physical network, so it can be routed to one of these external systems. So that's kind of the big high level. A few more things I want to talk about that. And I want to kind of emphasize this part, which is the SDN across the cluster. So right now there's a VXLAN overlay. That'll become important later on when I talk about some of the things that there are still challenges in the world of SDN with the containers. But this is just furthering the example of if you do have different zones and you want to be able to, or your cluster spread across lots of physical instances, this is the ability to do that. One other thing I didn't talk about also is, so we do, if you don't know, we do a ton of work. We work hand in hand with Kubernetes and Docker. In fact, we're the second largest, Red Hat is the second largest contributor to both of those projects. And one of the things that we work very heavily with Kubernetes on is the idea of network security policies, and particularly in our latest release, we have something called Egress traffic policies. And so what that allows you to do is say, well, not just any pod can go anywhere it wants to go, we can define where exactly those pods are allowed to communicate. So you might ask, well, what about the other direction? That's actually a bit more of a challenging problem because of the fact that now you have to consider things like load balancing and high availability, et cetera, et cetera. But there's definitely a huge amount of work and development going on right now with the community and our partners on improving the ingress side of that as well. And one of those, but one of the most common ways of getting traffic into the cluster is just simply using the built-in router that comes with it. And again, when you install OpenShift, this comes with it. You have a variety of options. This is the most common one. And the idea behind it is when traffic comes in, typically you'll have a DNS A record, for example, that says my whatever web server, maybe a globbing character for your web server or your different instances is going to point to some A record of an IP address, which maybe points to this particular router. That router then has the ability to do HA proxy load balancing and then redirect it into the system. And then the system can kind of take it from there and decide, okay, I know where everything is across all these pods. I know who to deliver it to. And maybe I want to spread it out. Maybe I want to round robin. Maybe I want to randomize where it goes. You have a few different options. And to facilitate this, we've partnered with organizations like F5, and so we've integrated their big IP to make this even better. So how does this all tie into OpenStack? So the idea here is what we're trying to do is build a foundation for choice. And so fundamental, as you can kind of tell, to all of this is the choice of SDN that's used and what its capabilities are. So what we worked very hard with upstream and partners on is this CNI interface. This container network interface is a pluggable interface where you can take your own third-party network solution and plug and unplug with maybe a different one that meets your needs. So we worked really hard on that with Upstream, of course. And in fact, we took our own OpenShift SDN, what I just showed you, and we are currently right now re-implementing it as a CNI plugin so that it can be swapped out if you wanted to. And I'll talk more about why you might want to and maybe what some different choices are. So why would you go CNI? It's just a much more complete plugin interface. It has a lot more options, and like I said, it gives you choice, which is really what it's all about, right? So what are some examples of third-party SDN solutions that are taking advantage of this? There's a bunch, and so I don't want to offend anybody by not listing them here, but for example, Calico Contiv, Weave, there's effort underway for Courier, and so on. So that's an important part of it. And finally, so what is kind of the state of all this? Like, what is, I have my example of OpenShift, what have I been using, and where are we trying to go with this? So currently with OpenShift, the reference architecture combination options are one of two things. The first one is just use what I showed you, the OpenShift SDN that's built into the product on OpenStack. But the issue with that is as you saw before, when you're communicating across nodes, you have to encapsulate it inside of a VXLAN. And so if you're doing that on OpenShift, on OpenStack, then actually you're double encapsulating the packets, so you take a hit in performance, right? So if you don't want that hit in performance, maybe you don't care, maybe it's not that big a deal to you. But if it is a big deal, you have an option. So we have heat templates that will instead swap that out for Flannel, putting it in host gateway mode, and then running that on top. And that goes with a more pure layer 3 approach to this. But then the gotcha there is because of the way it flattens out the network, you lose some of that multi-tenancy security options. So what do? Well, what Red Hat does is we're continuing to work with Upstream and our partners on developing further the development of additional SDN solutions, as well as trying to make them more enterprise grade quality, of course. So going forward, if anybody were to come to us and say, hey, we want to take our networking plugin and make it work with all this, then my first recommendation to you is, first of all, make it CNI plugin capable, and then after that, work with Upstream community and go forward from there. So, brief, but hopefully that was useful. Thank you for your time.